Hi, I'm Juan, and this is going to be a quick demo on using FlowStorm Clojure debugger. This video is going to be focused on flow tools and how they help debug and understand Clojure programs. First, we're going to use FlowStorm at the REPL so we can see the basics, and then we are going to debug a real application. In this case, it's going to be the ClojureScript compiler. Let's start by creating an empty Clojure project and add the debugger dependencies. This should normally be added on dev alias, so the debugger files don't end up in your final application jar, but for the purpose of this demo, I will add them here. Let's create a source folder, add an empty Clojure file on it, and start a Clojure REPL. The first thing we need to do is to require flow-storm-API namespace. Now we can run the debugger by running local connect. The debugger window starts empty since we haven't traced anything yet, so let's trace something. I say trace because FlowStorm is a tracing debugger. It means it can instrument any Clojure code and collect its execution traces while it's running. Let's write some Clojure code for calculating the sum of the first 10 odd numbers. Okay, now to instrument any Clojure form we want to run, just add rtrace before it, like this. Now, when the form executes, we will see the debugger shows the code we just ran. There's also a couple of buttons to step forward and backward in execution, and a panel on the right showing the current expression result. We can move through execution time by using next and back buttons, or we can also click around the highlighted expressions. If we change our form and run it again, it will show the latest execution. This is useful to work at the REPL. Now let's try adding some function. Let's try a recursive factorial calculation and trace it. This time we are using just trace instead of rtrace, since we are not interested in running, but just tracing the form. This subtle distinction can look confusing at first, but I hope it will make more sense when we start using flow IDs. Let's call the factorial from our original expression, and let's see what happens when we run it. At first, not a lot changed, but if we start stepping over the code, when it reaches the factorial call, it will show its code and step into it. Now we can step over the factorial function execution. Also observe that the bottom right panel now contains the current function local. This counter here shows that we are currently on trace 16 of 104 traces that our code has generated. Now, let's say we want to compare two executions side by side. For this, we can use flow IDs. So far, we haven't specified any flow ID, and everything is showing in the debugger as flow 0. Let's change that. We can set the flow IDs like this by adding it as metadata on the form. Now, let's run it and see what happens. Okay, now the debugger is showing two flows. Our original flow 0 and our new flow 1. We can do here all the same thing we did before. So that's for code stepping. Here at the bottom we can see more tools. The next tool is going to be our function called tree. The first node we see there is flow-storm running, which is the function representing an rtrace call. We can expand the tree, and clicking on nodes will display arguments and return values in bottom panels. As we see, only trace functions calls appear on the tree. We can check the same thing for flow 1. We can go back to our code view by clicking the first tab. Now let's see the last tool, which is the function list tool, by clicking on the last tab. It shows all called functions sorted by how many times they have been called. There are other tools here also, but we will see them when we debug the ClojureScript compiler. Now let's close everything and try something different. Let's try to instrument some library code, for example, Clojure string code. We can use instrument bar to instrument any Clojure function. Let's see what happens when we run join and step over it. It will jump into join source code, where we can move around as usual. We can uninstrument forms also if we are interested in them anymore. So when we run them, they don't generate any traces. We can also instrument entire code bases by giving instrument forms for namespaces a set of namespace prefixes. As we can see here in the REPL, after we run it, it's logging some details about namespaces it is instrumenting, form it is skipping, and so on. After instrumenting all Clojure string, let's see what happens when we run some string function like replace. Here we can see that we haven't executed anything yet, but the debugger is already showing something. First thing to notice is that instead of a flow ID, it is showing a small funnel icon. This is because something in our tooling has called that function, maybe cider or in REPL after it has been traced, and the funnel flow catches some traces about the replace function. We will ignore this for now, but this is something to consider when instrumenting something from Clojure itself, that is maybe being used by our own tooling and can generate a lot of noise. Let's run our call to string replace and see what happens when we step over it. As we can see, we can now step over all Clojure string functions being called by our replace. Before wrapping up the basics, there is one more feature I would like to show, which is about jumping around and repeating forms like loops. Let's trace again the execution of the join function over a list of words. We can see there is a loop here, so some of these forms are probably executed more than once. If we are only interested in debugging some of the iterations, it gets pretty tedious to reach that position by clicking next, especially for big loops. For those cases, when you click over a highlighted form, instead of jumping into it, FlowStorm will show a menu with all the execution of that form for the current function frame. Clicking on it will move the debugger to that position in time. And that's it for the basics. Now let's jump into debugging a real Clojure application, like the ClojureScript compiler. Let's start from an empty folder again and create a ClojureScript file to compile. We can use the same factorial function we were using before. We will just print factorial of 5 on the console. Let's compile it for nodejs and execute it by calling ClojureScript main with -t nodejs and our script as argument, just to check everything is working. And it works. Now let me introduce FlowStorm cli-run function. This command looks scary, so let's take it apart. First, we are starting a JVM with ClojureScript and FlowStorm dependencies. Then we are executing cli-run with some parameters. Instrument namespace has a set of namespaces prefixes to instrument, in this case all namespaces that start with cljs. Then there is profile light. FlowStorm can run in full mode, what we were running before, or light mode, for only tracing function calls and returns. This is useful in applications that can generate a lot of data, since we aren't probably interested in every detail of everything, but we will see how to add full instrumentation to things we are interested in after. Require before is useful for loading namespaces that are lazy loaded, so we can instrument them. Function symbol tells cli-run after instrumentation we want to call cljs.main, with fn-args, which are the same arguments we use for compiling and running in nodejs. Let's run it and see what happens. Okay, first thing, the debugger popped up empty while it's instrumenting all namespaces. After instrumentation is done, it is running the compiler, and now we see the same results as before. It takes a little longer to run the instrumented compiler than the uninstrumented one, because there is a lot of extra code running. Before looking at the debugger, let's take a minute to think about what do we expect a compiler like this to look like inside. Oversimplifying things, it should do something like this. Grab our source code file, parse its forms, analyze them, emit JavaScript, and evaluate that JavaScript within Node. With that in mind, let's see what happened with our tracing. As we can see, there are some traces on the funnel flow, but we will ignore them for now. Let's focus on flow 0. We can also see that the compilation process spawned a couple of threads, but let's focus on the main thread for now. We're going to start by looking at the call stack tree. So clicking around, we can see some argument processing code. Some empty environment creation before starting. Expanding every function call looks like a ton of effort, so let's use the search functionality. We can use it to search over a string serialization of function arguments. Print level controls how deep we want to serialize them in case we are dealing with a lot of data. Let's try to search for factorial, since it's the name of the function we created in the file we are compiling. Maybe we can find how the compiler compiles our code. I'll cancel the search just to show that hitting Ctrl G will cancel any action that's taking too long. Maybe because our print level is too much or because we have too many traces. I don't think this is the case, but we will see what to do in case that happens. We can click on the function call list, and we can see most of the top call functions we aren't probably interested in. So we can select and uninstrument them. After removing them, we need to rerun this flow by clicking the rerun button. Now let's quickly search for our factorial function again, and it will find a function call that contains factorial in its argument much faster. As we can see, evaluate form contains the file and form for the factorial function. Looking around, we can see how the structure we were looking for starts to arise. Form seek gets the file and returns a list of forms. That was our parse step. Then inside evaluate form, we can see analyze, emit string, and node evaluate, which is exactly what we're expecting to see. Now, let's see, we are interested in looking at this evaluate form function for this specific call. We can right click and click on go to trace. This will take us to that specific function code. we can see that we can't step on it because we trace it with a light profile. But if we are interested in this function execution, we can right click and fully instrument this function. Then again, we need to rerun everything and quickly come back here. And now we see the function body traced, and we can step and click around it. Also, by looking at the highlighted form, we can see what part of the function execute for this function call. Now let's check other tools that are interesting for understanding programs like this compiler. Let's go to function calls and see what it shows for the compiler in more detail. First thing to notice is there is different coloring. Here FlowStorm is showing normal functions in black, multi-method calls in magenta, and the green ones are protocols or type functions. It looks like this multi-method parse is being called on ns form 85 times. Let's expand all these calls to see what's up. Okay, it's kind of hard to see how all these calls are different because their first arguments are the same. Let's check the multi-method code by clicking on Go to Trace for the first one. This should take us to the Code tab and show the code. Looks like the third argument contains the form that's parsing. So let's go back to the function call tab and use the tool at the top so it only prints the argument we are interested in. Then do show function calls again. Now we can see all the namespace that forms this parse is being called on. We see our namespace here at the bottom, so let's go again to this function call. Let's instrument it, rerun, and come back here quickly. And now again, we can step over this part of the code. So this is all I have for this demo. You can try to do the same with whatever project you are interested in, understanding its inner workings like DataScript, the Clojure Dart compiler, or your REST APIs. I will leave in the description all the commands we ran on this demo, together with the link to the GitHub repo. I hope you have a nice day. Bye!